today is I want to spend a little bit of time talking about what data cloud is all about and what customers do, why do they need data cloud, and what is the reason behind a concept called data cloud. And then quickly introduce you to Salesforce Data Cloud that we have built. And then my colleague Palani will come in and talk about the architecture in which we built the data cloud, and while we were building, all the gotchas and all the wow factors that came along as we built in the last 2 to 3 years this data cloud platform. So that's going to be the agenda today, and we'll be more than open to answer any questions throughout the session. So please feel free to ask any questions when you are listening to the talk today. So the main agenda would be, I would try to cover, as most of you said, data on cloud. I want to say why data on cloud, what is it that what the people are looking at. Then I'm going to also speak about what data cloud actually encompasses, what does it mean to have a data cloud ecosystem, and then I'll hand off to my colleague to talk about the architecture that we built for this data cloud ecosystem. Okay, let's move on. So every company wants to find some unique ways to reach their customers and build capabilities across their ecosystem. So as you see, over a period of time, companies have grown and they have built massive enterprise systems. Good examples even within India, right? So if you take Airtel as an example, Airtel has probably grown over a period of time from one spectrum to another spectrum. Different companies do different things today as they grow their businesses. Now, customers for these companies span across these businesses, and these companies want to give excellent services and provide capabilities to their customers across their bandwidth, and they want to also ensure that they give the flavor of their new brands and also ensure that the customers can walk the journey across different brands that they have in their enterprise systems by knowing their customers better, right? Now, typically enterprise systems claim that they will be able to provide better customer journeys and they will know the customer better. But if you understand from a software architecture one-on-one, none of the companies buy the same vendor again and again and again, right? So they end up buying different vendors, and at the end of the day, what happens? You as a person who has gone to this brand, you as a person gone to this brand, you as a person who has gone to a different brand is the same person for that same company, but at the end of the day, you are being targeted in different ways at different levels by the customer, saying that, okay, you are part of my brand, so I'm trying to sell you the other brand as well. So one of the key aspects is unifying your profile, and you might have heard this in many scenarios in technology terminologies like master data management and companies bring in. So master data management is probably one scenario of a data cloud ecosystem. Okay, so there are many such scenarios, and I wanted to kickstart this discussion by giving you a simple example where you as a person, and if I can identify you across the spectrum of what I do as a business, that's where data cloud comes in the way. Okay, so let's take some simple examples of different verticals and horizontals. Can you move to the next slide? Verticals and horizontals where data cloud plays key or significant role for any customer. And if you are in a marketing vertical, you would want to optimize the return on the spend that you have done for your campaign management. So you would want to target the right segment of people who would potentially buy your product, right? So let's say, for example, you are trying to campaign for a new baby cream, right? You would probably want a segment of customers who have probably ventured into the store, whose age group is between 28 and 35, who have probably bought a diaper recently, right? And who have probably gone ahead and done a medical insurance for their kid or a family insurance for his kid. So if you look at it, one is a retail store example, another one is a diaper product example, another one is insurance sector example. So you are probably bringing data from various different sources and trying to segment a customer section that would potentially buy your baby cream, right? Now, this segment of customers that you would want to get, you would need to bring data from various different systems and try to make sense out of it. And this is where Data Cloud comes into play. And that's a very simple example of a marketing scenario where you would want to run a campaign, and to run that campaign, you would want to find a set of people who would potentially help you build your campaign much better. Similar examples, I'll take one more examples where, let's say, you are looking at you are providing support to a lot of a particular customer, and you realize that this particular customer is reaching out to you from various different channels, right? And you're trying to solve his problem by either sending him devices or probably sending an engineer to his house to solve the problem and stuff like that, and your resources are spread across from a person, engineer visiting, a particular machine being sent to him. If you know this customer better, and this is the same customer whom you are dealing with again and again, you'd probably forecast the resources that you need to support this particular customer, right? So knowing a wide spectrum of your business, bringing it at one umbrella, under one umbrella, and trying to make sense out of it is where Data Cloud comes into picture. There are a lot of such use cases, and that thing talks about it. Now, I want to quickly switch gears from a use case kind of a scenario where saying that, okay, these are the reasons why a company would want to use Data Cloud. How will they go about using Data Cloud? What are the benefits of using Data Clouds? The first two slides were basically trying to talk about it. But as an engineer or as a data architect, if I am in one such companies and I want to achieve all these broad spectrum of capabilities, what needs to be done is a complex white paper that was written by somebody saying that you need to build all these. You need to have all these capabilities and these scenarios in play for you to achieve each one of those capabilities that you're talking about. Whether you want to do a unified reporting, you want to do analytics, you want to do machine learning, you want to do identification of master data management, all these are Data Cloud capabilities, and which are basically a heterogeneous set of technologies that kind of calls out that you would need these kind of technology stacks, which has to be brought together and streamlined, and different kinds of processes being pulled in, different kinds of streaming that has to be done for us to achieve the end goal. This is, in a nutshell, a simple implementer's view of getting through these scenarios from a scenario of a Data Cloud standpoint. Okay. Now, probably not only that you have to build multiple technologies, you also have to look at those technologies from different scenarios perspective. Like, for example, in some scenarios you would probably want to send the CEO or CTO a daily report. In some cases you would want to have instant analytics. For example, you are on a Flipkart website and a customer has clicked on add to cart button for like 15 times, and the moment he clicked the 15th time, you would want to send him a promo code saying that, hey, you have 15 items in your cart, I'm probably going to give you 10% discount on the item because you've clicked 15 items in the system. And this has to happen before he actually moves away from that page, right? It's kind of real-time processing. So there are scenarios where you would want to take decisions within a small period of time, and there are decisions that you would probably take over a period of time, which we, in our world, we talk about streaming, we talk about batch processing and those kind of capabilities. Both are necessary for a Data Cloud kind of an ecosystem where customer would want to handle these kind of capabilities. Now, naturally, wherever there is data, there is the school factor talking about machine learning, right? So we always talk about we want to have machine learning because there is large volume of data that I have kept in one place. I would want to mine that data, I would want to read the data, and I want to take better decisions on this data. Now, it is imperative that it is not the matter of machine learning as a cool factor, but the use case of a machine learning makes a lot of sense in today's world. If you take a good example of one of those food delivery vendor companies, right? They take instantaneous, predictable decisions on their delivery partners and their delivery ecosystems in a matter of a fraction of a second. And the transaction volume is so huge, especially if there is a festival coming or a holiday coming, the amount of transactions runs into billions, and that is per day, and millions per second. That is the rate at which these systems operate. And at that rate, you should be able to support scaling systems that not only handle data that is coming in and going out, but you should also be able to handle models and computations that are able to predict and generate the output that you need at any given point of time. Now, this is the system that we talk about as a data cloud. So, what are the key challenges of data cloud? The sources. One of the key things that you have to deal with when you're talking about a data cloud is where all the data is coming, right? So there are different sources in which data can come in from. So we've kind of made a list of all the data sources that are potentially possible, right? So there are different ways in which you can bring the data from each other. Then the size of the data that comes in, right? If you're talking about click streams, or let's say you're walking with your phone around and your GeoNode information is coming every millisecond of the day, you're probably handling about 50 billion events coming in matter of a day, right? So that's the volume of data, and you're also dealing with the variety of data. So some people are ingesting data that are coming through emails and other capabilities. The structure of the data is different from each one of these systems. So velocity, volume, variety, and veracity of data. Veracity, what does veracity means? The variability of data. There are different types of data that is coming in for different ecosystems. So it's basically, you're talking about a person's identity, you're talking about a car's identity, you're talking about something else's identity. Good example is, all of you have these fitness watches. Hundreds of different types of fitness watches are there, but at the end of the day, heart monitoring is the same, right? You would want to make decisions based on if a person will get a heart attack or not. If you're trying to build such a capability, and if you're trying to build in an ecosystem where you would want to support hundreds of different types of devices, then each one of them is sending a different variety of pulse rate information based on their own ecosystem, right? So that's variety of data. So you're getting same data in different patterns. The final ecosystem is, after you have got the variety of data, velocity of data, volume of data, if you've handled all these capabilities, the net outcome of a data cloud ecosystem is what is the value that you're generating, right? This data, if you're doing a machine learning ecosystem, you're building analytical platform or doing something, at the end of the day, it should make some sense. It's not necessary for us to bring all this data together unless and until you have a scenario in mind. In this case, we wanted to say whether a person will actually get a heart attack or not, right? That's a value that you're trying to get out of that particular system. So that's the important use case of building a data cloud ecosystem. One, you handle velocity, variety, and volume of the data, and at the same time you extract some value out of this data. And at the end of the day, after you take the value of that system, important aspects of that particular value is what value does it make sense to a specific ecosystem. That's the most key aspect where most data cloud systems or data ecosystems fall short. Because you might have all seen that you have a platform ecosystem where you would ingest data into a lake like Snowflake or Redshift or something like that, and then you ultimately write a report and you are done with it, right? But what is the ecosystem value of that particular data? As in, can I actually make sure that when a service agent is opening and talking to a particular customer, can he get some ecosystem value at that instant of time, saying that, okay, this particular customer had done the following things in the past 2 months. The next best action that you can take to this particular customer is this. A good example is, let's say you're buying a Titan watch and you have bought it yesterday, and today you go to a Tanishq showroom. And how would you feel if the Tanishq showroom representative asks you, how was your experience in Titan Plus? Because Tanishq and Titan are of the same brand, right? In Tanishq showroom, if he comes and the sales representative asks you about your purchase experience in Titan, then you actually feel empowered that Titan as a company values its customer across its brands, right? Now that's the ecosystem value that you would want to provide as a part of ecosystem. Then a lot of you are now scared already, right? If you're talking with our phones on, you'll probably receive an ad on that particular ecosystem in a few hours or few days or something like that. You will probably hear. That's one of the ecosystem values as well. That's because most of the people end up targeting customers where they are. So if you're constantly browsing your Amazon ecosystem, or you're browsing your Facebook ecosystem or Google Ads ecosystem, regardless of what platform of data cloud that you use, you need to reach the customer where he is more comfortable. You cannot say that you come to my website to see my ad, right? You need to target the customer where he is actually more capable of responding to your ad ecosystem, and that's the ecosystem value that you talk about. Now with this, I want to also point out that all these things are fine, but at the end of the day, every data that flows through this data cloud ecosystem needs to honor certain basic capabilities or governance rules, and also need to provide capability for your customer, so that, or your vendor who is building the such a kind of an ecosystem, where he will be able to do the whole thing without actually writing codes, right? If you're going to Databricks platform, or if you're going to go into Snowflake the platform, if you have to build this entire ecosystem from one end to another end, there are parts of it you would probably want to use the capability of drag and drop on their UI. Parts of it you would want to write an extensible code. Parts of it you would want to probably use their out of the box capabilities and libraries to induce into the system. And finally, there are also systems wherein you should be able to set that for my data cloud system, the key player is a hospital industry. So patient demography and some of these things are PII information, and I don't want certain parts of the data to be not visible to certain people, so there are things when you're talking about fintech systems, when you're talking about hospital systems, there are governance rules that govern the larger data ecosystem, and your big data system should be able to honor it. You cannot let go of those capabilities, and those tool sets are also available or needed for building a data cloud ecosystem if you start building one from one end to another end. So these are the practical considerations when you want to build a data cloud system from one end to another end, and there are various ways to do it. And we embarked on one such approach, and we built a data cloud system that would potentially build this system. So with this, what we did was we built a system called Salesforce Data Cloud. Salesforce Data Cloud is a very interesting and a unique platform. We took, it's almost our third year running, and we have been handling significant load on our Salesforce Data Cloud ecosystem. One thing that you should understand is our data cloud ecosystem is a zero copy architecture. What it means is, not only do we support bringing in and ingesting data from various different sources, we also support customers not to move their data from their existing warehouses. So what we are trying to say is, if there is a customer who is using Snowflake or data warehouse or something like that on his own, and he doesn't want to shift his data all the way into Salesforce Data Cloud ecosystem, we can virtually view that data and operate on that data. So that's the ingest part of the story. So we support various types of ingestion ecosystems that run at petabyte scale. So in fact, one of the good customers for Salesforce ecosystem is Ford, wherein we handle about more than 1,000 requests per minute coming in at any given point of time. In fact, when a car is running, it is sending an event. We resolve the customer of that car and then send him promotional events. This is running production and live today, right? Now, throughout the ecosystem, we have built capabilities in the last 3 years that are petabyte scale, and there are interesting architectural challenges which I would request my colleague Palani to walk you through on how we went about building it and what are the challenges that we faced through. Palani.
Let's start with the storage layer. This is our architecture. At the storage layer, we have 4 different stores. One is the actual data ends up in Lake, which is S3. And we use Iceberg as our table format and Parquet as our file format. And that's file storage. That's where the real data that is ingested lives. And then some of the data is also pulled into hot store. The purpose is like, given a mobile number, I want to know about this customer and all his latest transactions. So the profile information is pulled into hot store, which enables all external apps to build on top of it. And then we have a SQL metadata store, which is like, you define a aggregation. I want to summarize all the sales by region, by category, product category. So that's a definition of a summarization. So that metadata goes into RDBMS, RDS in our case. And then we cache all the metadata and security for various processing applications. So that's our storage layer. That's the bottommost one. You go one level up, we use Spark for most of the data transformations, whether it is aggregate or data cleaning or whatever other transformation that has to happen on the data, we use Spark. And we use Trino and HyperDB as our query engine, whether it is BI integration or interactive analysis, or a user wants to run SQLs to analyze their data or understand their data. We use Trino and HyperDB. HyperDB is all Tableau online workload is being driven by HyperDB. It's Salesforce acquired company. And then we use Airflow for all our orchestration across Spark jobs and across workloads. We go one level up. We have three types of entities. We call data stream and data model. Data model is a logical constructs on top of data stream. And then we have a special entity called event entities, which is whichever is ingested from your web SDK or mobile SDK, whether it is a clickstream or the browsing history, right? So all these different entities are done with ETL transformations, bunch of ETL transformations that we do. One level up, this is our app layer. So below is platform layer, this is our app layer. In app layer, we have identity resolution. What does it mean? Palani from Service Cloud, Palani from website, Palani from mobile is the same Palani. So how do I do that? With identity resolution, right? That's master data management piece of it. Next is segmentation. I think I gave a very good example about segmentation where you want to target customers for a baby cream that you are introducing. How do you do that? You look for specific customers who did some specific transactions in your system, right? So that's segmentation. Real-time profiles, it's like, a customer is an anonymous customer till he logs in your website, right? So he's browsing through. He has added some of the items in cart and he's about to make a purchase. So that time we will ask him to register. So now he is registering it. The moment he registers, you want to look up, hey, I know Palani now. Can I see what else he has done in the past in my any of my companies, right? So that's real-time profile identity. And then query services, it's again, we support different APIs and allow SQLs to be run against your data. So that's query services. And we have Einstein prediction. Salesforce has ML platform called Einstein, and you can use with a bunch of clicks, you can set up a model and start running against it. You can predict your propensity to buy for a customer, right? So that's Einstein predictions and activation. Activation is nothing about, hey, I have found a target customer. Now I should be able to target them in a Google ad or a meta ad. So that's activation. So this is our app layer. On the left, we have bunch of connectors. There is a first-class integration with all Salesforce products, and there is open source, generic connectors as well for bringing in data from various other sources. And then we have a control and management plane for CI/CD and DevOps. And then on the right, you see that there is a BI. Any BI tool can be integrated. We have integrations with Tableau and Datarama, the two BI tools, and then activation channels, whether it is Salesforce Marketing Cloud or Google Ads or Meta Ads, you can get them integrated. So the key difference in Salesforce Data Cloud is that it is built on Lightning platform. So what does it mean? So if you are a systems integrator, you could come in and build a vertical application called air travel application, which can be used by any travel industry, which will come up with pre-aggregated reports, pre-aggregated segments, pre-created segments like frequent flyers and things like that. So that's our Lightning platform. That's a unique thing about Salesforce Data Cloud. Right? Let's dig a little more deeper about data architecture, right? Where all data flows and what all we use, right? So if you see, we have event streams coming in from various sources. We have batch streams coming in from various sources. Both of them end up in Lake, which is our S3 back one, iceberg tables. And then we have all these applications which operate on that. And then the unique thing in our Salesforce Data Cloud is that we support change data capture, which is for a big data system supporting that a new profile has been inserted, a new profile has got changed, his email address has got changed, right? So that's data change actions which can be sent out to any web code, right? So if you want to build a downstream system where you want to pull in all the information back into BigQuery or Snowflake or any other system, you could use change data feed. So we use Spark in all these layers, and we use Trino for ad hoc query explorations. Right? So change streams at all levels. This is one of the key aspects of our architecture. So the data lives in the lakehouse, and we have Spark stream processing, which will look at every change feed. So if you take segmentation, let's say that you have identified all the customers to target for promoting a baby oil that you are coming up with, right? So that has already run, and now more sales have happened. Now you want to rerun that segmentation. You don't have to do it again all over from the beginning, right? You could do it only on the changes that has happened, the new sales that has happened, the new changes that has happened to a customer, right? So that's done via the change feed. So this slide gives a bit of intro, a view about the scale that we handle. This is per tenant. We support 50 billion profiles, 1 trillion engagement events per customer. We support 5,000 tables, which a table can have 1,000 columns, and data streams of up to 5,000, and batch ingestion of 60 minutes. We see the profile API. It's a 30K queries per minute at 375 milliseconds latency, right? So that's our load. Next one. So let's talk about some of the interesting challenges we went through. The first one we are going to talk about is ingest. So if you see on the left, I'm going to list some of the problems that we face. One is users are asking, hey, I want to ingest a billion row in an hour for a tenant, right? So if there are multiple such tenants, how do we handle? And the event ingestion, they're asking for 100K events per second per tenant. And then multi-tenancy is a major problem. All of this is built as a SaaS platform. So what is our principle? How do we do that? We have a Spark job as a service. We have built a framework for that. We bring up cluster dynamically based on load. We bring up whenever we need, bring up a Spark cluster or deprovision it. Next one. We have something called tag-based routing. What does it mean? Every job from different applications will have certain properties, and the cluster will come up with certain properties. So we do, convert the properties into tags for the job, and there are some tags for the cluster. We match based on the tags to find the best cluster to run this workload, right? So that's tag-based routing. Cluster sizing on tenant metadata, which is like, I know that the job is going to touch these many billions of rows, these many, these terabytes of data. So I can size my cluster on which the job is going to run in the right cluster sizing. So the above one is for batch. The below ones are going to be for more of eventing. We have topic per tenant. So if we create a topic per tenant, and if there are 100,000 tenants, what do? We have multiple Kafka cluster. We use parallel consumer, which is like we don't want one table change feed pushing out to block other change feeds, events to be pushed out. So we use Kafka parallel consumer, and we have it's like if you run a Spark streaming job, we don't want to run too many jobs because its cost to serve is going to increase rapidly. So what we do, we pack multiple streams as one job, and we use min executors for streaming cluster. What does that mean is, let's say that there are 10 tables that I'm listening to, 10 streams running in. I don't have to listen to, I don't need an active core for all the 10 streams, right? I need for the one where changes are happening, and I don't want to, dedicate a core for the one where there is no changes. So that's min executors configuration. And we also do cross workload stream processing. Now let's say that a table has been ingested with new set of data. Now I can do multiple workloads on top of it. I can incrementally build ID, IR, segmentation, and activation. All of this different workloads can happen on single stream. So that's cross workload stream processing. Yeah. Next is process at scale. Again, volume of data and complexity is a big problem for us. Data skewness is another big problem. One good example is one of our customer, we create indexes in DynamoDB on first name or email, right? One of our customers had all first names as null. So what happened is all the billions of data ended up in one physical partition of DynamoDB. That partition, became hard, and the ingestion ran for hours. It never completed. So data skewness is a very big problem for us, and multi-tenancy is another, major problem. So what do? All we did for ingest, we do again for processing as well. So we strive to do event-driven. We don't do hourly, segmentation. Rather, we do segmentation on event. When the ingestion completes on the impacted tables, then I want to do my segmentation processing. So it's all event-driven. We have all metadata at storage layer. We don't want our SQL RDBMS store to become a bottleneck at any place. So all the Spark jobs, whatever metadata it needs about the relationships of entities, that is also kept in the storage layer itself for it to access. And change feed at all levels. So change feed on a logical construct is not easy. What do I mean by that is, let's say that I have a materialized view or materialized construct where I compute average selling price per category. Now there can be new set of records ingested, and the new computed values, still the average could be the same. So what is materialized is sum and count, but the average is what is user sees, right? So providing a change feed on a logical construct like this is not trivial. And we have incremental processing as much as possible, and we limit the engagement data. What do we mean by that is we don't allow customers to create segments where they want to analyze the browsing history 5 years before. The website itself would have changed, right? So we limit the engagement data while creating segments. Next one. So deliver at scale. This is where we send out events, right? Whether it is change data feed or the example that Adithya talked about, right? The customer has added 15 items in cart, and then I want to run bunch of business rules behind the scenes, and then reach out to the customer, right? So that's delivery. So what is the problem? We have to deliver to different target systems. Customers are asking for 1 billion event delivery per day, which is like 11,500 events per second. That's at one tenant, right? And multi-tenancy. So what do we do? Again, parallel consumer, multiple Kafka clusters, topic per tenant, and this is an interesting piece, right? Tenant consumer as a container. So what do we do is we don't have single microservice which is listening to different Kafka topics. Rather, if we know that this tenant has a high throughput, we create a separate container for them and run it as a separate pod within the Kubernetes ecosystem, right? Can we move on? The next one. Yeah, query at scale. This is my favorite topic. We have three different classifications of query. One is like interactive query, which is for external applications, where the expected latency is 100 milliseconds at a very high throughput. Second is again interactive query, but this is like a little more less constrained. Yeah. I'll just finish with one last thing. We'll move to the next slide. So this is a simple query that was run by a customer. There is nothing special about this, but this made our engineers struggle for a couple of hours to understand what happened. So it took down the, it impacted multiple customers. So what was the problem is, the union is the problem here. So if you see entity brought in 6.2 billion records, the other entity brought 4.8 billion records, and we were trying to do union, which is like deduping 11 billion records across these set of fields, which ran for hours. So we are very good at putting retries, right? So the actual user action was dragging in a particular column in Tableau for creating a filter. I want to know the unique channel action, right? So that's what user did. That created a query like this, which ended up taking down our thing, because we started doing retry after every timeout, which ran more of these queries, which took our cluster more.